case. So this presentation is going to be a little different from what we've heard so far today. It's going to be a little bit more technical. I'm not going to get into any of the code, but let me get started. So my name is Kunal Batra. I am a senior technical evangelist at Amazon Web Services. And this presentation is going to be on machine learning for sustainable development goals. I'm actually on the other end of the spectrum where I come more from the tech and learning about the sustainable development goals from kind of that previous discussion that we were having before. So just to calibrate any questions that you might have during this presentation or afterwards, a little about me slide over here. I, again, am a technical evangelist at AWS, which essentially just means I'm an engineer who builds awareness and adoption of our offerings. I've worked at a lot of developer-focused companies. If you have any questions on any sort of those verticals that you might have heard before, feel free to reach out. The best way to get in touch with me with the fastest response is my Twitter handle there, Kunal732. Definitely faster than the email. I will have my email on the last slide. And I'm really into machine learning and computer vision. I love building on the tech of that. So you can see this image over here. It's actually counting how many people are in the Shake Shack of Madison Square Park and seeing how fast that line moves. And another app I built just showcases when the garage door is open or closed for my parents. They love that. They always forget when it's closed. So if it's open for more than 5 minutes, I send a text message to them using AWS. So I'm really into this stuff. It's kind of a hobby for me. It's kind of a passion. And then this presentation will be talking a little bit about computer vision and then how it can be used for some of the sustainable development goals. So the agenda for this presentation is going to be a little bit of those machine learning basics. I wasn't sure what the audience was here today. So if you're not familiar with some of these basics, this will be great. If not, don't worry about it. Talk a little bit about some AI use cases for sustainable development goals, and then how you can use the Amazon ecosystem to build a model for that. And I know, again, this might be a little technical, but if you have any of these topics here, feel free to ask those or tell those to your developer, or reach out to me if you have any questions. All right, so just to level set the audience here in terms of terminology that's used, I feel like this is something that people have seen a couple of times, but we tend to see this term AI and ML used interchangeably, and it's not the exact same term, right? So artificial intelligence is any sort of computer system that can mimic human intelligence. And machine learning now is one subset lower of that, where now it's actually learning with data. And there are three real popular types of algorithms that you see in machine learning, and those are supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is kind of like the example I gave before where I built that app for my parents, whether the garage door is open or closed. When you train a supervised learning algorithm, you need to give it labeled inputs, right? So for that example, I had to give it labeled inputs of my garage door in different situations where it's open and in different situations where it's closed. And that's supervised learning. Now, unsupervised learning is, there is no labeled data. Basically, you are creating an algorithm where it likes to look at the attributes of your inputs, and it does things like clustering based on similarity. And reinforcement learning is my personal favorite. We won't be talking much about it today, but I do teach a lot of it at our AI ML boot camps in the city. But reinforcement learning is where you learn a lot about, learn through the consequences of your actions. And so essentially, you're creating a reward function where you kind of tell your algorithm what behavior you want it to keep doing. I actually really like it a lot. AWS just released this car to showcase how you can create an autonomous car with reinforcement learning. So we teach that at our AI ML boot camps. It's open to everyone. It happens, I think, once or twice a month in the city. And so for this session today, we're talking about supervised learning. And essentially, with supervised learning, what you're trying to do is understand the relationship between the labels and the images, right? So over here, you can see that I have these images and there's a label corresponding above it. Now this data set over here is just a bunch of images that are hand-drawn integers, and you can see the labels provided above it, so 7, 3, 2, 5. And the whole purpose of this machine learning algorithm is to understand how those labels are related to those images, and then train a model where you can now give it new inputs that it's never seen before and get the right predictions from it, right? And so this data set over here is actually a really popular data set in machine learning. It's called the MNIST data set. This is something that you're going to see, or will see if you ever start tutorials in computer vision to learn about. It's really popular. It's around 60,000 hand-drawn integers that have been given labels by humans. So it's a high quality data set, and it's a great way to learn ML algorithms for computer vision. But in this case, we're not going to be talking about the MNIST data set. The goal of this conference was Sustainable Development Goals. And this is something that's new to me. I definitely come from a different background. My little brother's actually studying policy, and so he was kind of walking me through Sustainable Development Goals. And we were trying to work together, how can AI be, use cases be used for Sustainable Development Goals? So one of the things that AWS has and stores is a lot of satellite data. And if you go to aws.amazon.com/earth, we have a bunch of public data sets, right? And the one thing that I've seen is that there is more satellite data now than ever before. And there's more precision to measure our environment with this satellite data. And so some use cases just really quickly that I thought AI and computer vision could be great for was first, do any sort of these human perception tasks, right? Taking a look at satellite feeds for crop monitoring, taking a look at if there's pollutants or toxins in any water from satellite feeds, and then deforestation or forest degradation. So I wanted to showcase in this talk how you can use the Amazon ecosystem to build out models for these use cases or other use cases regarding computer vision. And one of the things that we see with machine learning and computer vision is it's a complex process, right? And there's three major steps that come when you create your model. The first is you need to do that data wrangling. You need to get all of that data, and then you need to be able to label it. And then from there, you need to go train it. And that requires a lot of iteration to make sure you have the right type of model answering your questions. And then finally, you need to deploy that model. So it's a complex process. So with AWS, we introduced a service November 2017 called Amazon SageMaker that really tries to simplify this service, right? And so it has a bunch of things, a bunch of different services here that make it easy to build, train, and deploy your models. And one of the things that I find really important, and it's not sexy at all, is ground truth, where it's labeling that data, right? So it's not even training that data, not even creating that algorithm, not even using it. It's just creating that data set, right? When we talk to our customers, that is by far the most complex thing that they have to deal with. So we wanted to give an ability for them to make that easier. So we created ground truth. And just to kind of put this into perspective, one of the questions that we get asked a lot by customers are, how much training data do I need for my use cases? And some of the responses we give back are, first you need to consider what's the cost of making a mistake when you're creating that data set. What are your accuracy requirements for your model? Is 99.9% accuracy good enough? If you're creating a self-driving car, if something goes wrong 1 out of 1,000 times, is that okay? The other is diversity of inputs, right? So if you have really diverse inputs in your data, you'll need less training data. But if it's less diversity, like satellite imagery, you're going to need a lot more training data. And so this is a difficult problem to label, right? Now that you require really large training data sets, you need a large number of humans to label that data. And then the more humans you have in the pipeline, the more ability there is to make a mistake, so you have lower accuracy. So we wanted to help speed this up. And so with the SageMaker Ground Truth service, it lets you quickly label training data, integrate with other human labelers, and get accurate results. And I'll showcase demos of this towards the end. And so some of the things that I think that are cool, what it does is first, it makes it easy to give your data to human annotators to label that data. And we'll talk about the different pools of human annotators that you can use for that. On top of this, it also has something called active learning, where you have the ability not only to just have humans label your data, but with such large data sets that gets expensive, it can also start learning a model based on how the humans are annotating that data to also label that data set. And with ground truth, it makes it super easy to go ahead and do certain things for your annotators, like do bounding boxes, image classification, semantic segmentation on that data. And some of the things I mentioned before are the different workforces you can use to label that data, right? So with Amazon, you can take advantage of our public workforce. Actually, this is a better slide on it. Mechanical Turk, which is over 500,000 people who can label that data really fast for you. If your data does require subject matter expertise, you can take advantage of a private workforce and still use our services for that labeling. Or you can take advantage of third-party vendors through the Amazon site. And so with data labeling, it's not only making it easy to label that data by having integrations with human labelers, it's also about improving that label accuracy so you have a really high quality training data set. And one of the other services that we have is something called annotation consolidation. So when you have a really large data set, you want to have multiple people look at that data and label it. If you just have one, there's a possibility that it could be wrong or that something can be tired and classified incorrectly. So if you have more than one person who is looking at that data set and that piece of data and labeling it, how do you know who's right? So we introduced something called label consolidation, right? So now let's say someone's looking at a data set that you want labeled, and for example, let's say it's a dog data set. You have 4 people who are going to label that data. By the way, does anyone know what dog that is? Sharpei? Are there anything else? Sharpei? Okay. So let's just say that you have 3 people who say bulldog, 1 person who says Sharpei, and you're getting this data set labeled. If you have majority voting, this is going to be a bulldog, which is incorrect. But if you take advantage of probabilities and the Bayes theorem, now you can start getting more accurate results. So essentially now, you're actually having these people label that data, but you're also keeping track of how accurate their labels are, right? So by having both of those together, you're able to see that the Sharpei is the right answer. So when you're labeling these massive data sets, that high accuracy is really important. So we want to make sure that you have access to stuff like this right out of the box to make sure you have the high accurate data. And if you're not training your own data, you can also take advantage of data sets that are stored on AWS. So you have SpaceNet that's stored in AWS. And again, you can go to aws.amazon.com/earth to see a lot of those other data sets that you can take advantage of. Another tool that I really like is Label Maker. I don't know if anyone here is a developer or they want to mention it to their developer. It's a great way to get access to really quickly to label data sets. So that's the actual getting the data to build your model. Once you get that, SageMaker provides a whole bunch of built-in algorithms that you can take advantage of. So we have computer vision algorithms over there where you can do image classification that tells you what's going on in an image, object detection, not only what's going on, but where it's happening in an image, and then semantic segmentation where at the pixel level, you can see what's happening, right? So let's say you want to see all the buildings or you want to see highways on a road, you can do semantic segmentation and just be able to just get those markers with that. From there, once you have that data, you can go ahead and train your model with SageMaker. Again, just pick that algorithm that you want, go ahead and train it based on that when you give it your data sets, and you have a model. This is a link where you can go ahead and learn more on ml.aws. I also wanted to showcase a couple of things on AWS. So let me just get out of this PowerPoint presentation. I'm just going to go into my browser. And for anyone here who's never experienced AWS, basically, you just go to console.aws.amazon.com once you have an account and have internet. I forgot to connect to Wi-Fi. Is there a free public Wi-Fi here, or which one is it? On the table? Thank you so much. All right, so just get that really quickly. All right, so once I connect to the internet over here, basically you just go to aws.console.amazon.com. You can see a whole bunch of services that Amazon provides over here. It's actually a lot. It's 165 different services. But if you scroll down, you can see the machine learning section over here where you can take advantage of SageMaker to build your own AI model. But let's say you don't want to build your own model. Let's say you maybe want to take advantage of some model we've already built. We have a fun little service here called Recognition. And I'm just clicking on it. You can actually go back there and just search for it and just type it in. I think it's easier to do that as well. But basically, you can go to recognition, and this will let you, you can try the demo, so you don't have to be a developer for this, but you can see what Amazon will give you if you don't need the granularity of creating your own data set, right? So I'm gonna go ahead and upload a photo. I have this photo already set over here. I'm gonna go ahead and upload it. And as soon as it's done uploading, you'll be able to see a couple of things. It's stuck at 54%. Okay, so while it's uploading, this is the photo that I'm uploading right now. It's just a photo that I got from an aerial view, satellite view. And it's an airfield, airports, and a bunch of cars over here. And as soon as this loads with AWS, it'll tell you right away a couple of airfield, airport, airplanes are in the image, and it'll point that over here. So you can see that right now, airport, airfield. You can see how confident it is that these certain tags are in the image, right? So if you have a use case where you don't need to kind of create your own models for that, you can take advantage of a service called Recognition to do that. But if you do want to create your own models, and you can actually take advantage of other public data sets, you can do really interesting things like count cars, right? So you can see, like I don't know if you can see over here if I keep zooming in, but there are a lot of cars at this airport. And so I ran it through a model that I trained last night, and it outputted this long file. Let me just showcase the file. But it outputted this long file, but basically it's saying that there are 1,111 cars in that photo, right? And basically it'll tell you the coordinates of those cars, and then you can go ahead and map all those coordinates back on that image. But there's so much you can do with publicly available data sets with this as well, where you don't have to train your own data sets. The other thing I wanted to showcase as well is that when you build a model with SageMaker, you can download that. That's all your own. You can bring that to your own laptop and do whatever you want with it. I just created this one last night just for a fun little demo. So let me just go to that. Hope it works. And basically, I trained this model it's with a publicly available data set on SageMaker and downloaded that. I don't know if you can see it here. But basically, it is just, that does a couple of different classes. So it's detecting, like, I'm a person right now, just showcasing that. And then basically, this model was trained on SageMaker. It's on my local laptop, and it's just making inferences right now. So you own that data. It's all yours. Awesome. Any questions so far, guys? Yeah, go for it.
So how exactly do you judge the quality of your training data set? Are there any statistical tools to do that? You mentioned there's a lot of manual labeling involved. So once you have the training data set, how do you say whether or not it's quality?
Whether your data set is quality?
Yeah.
Well, is it answering, when you have that data set and then you train your model, you can do a couple of things. Once, you can take advantage of a confusion matrix, which is just a way to see how well your data set is, how it's working. Is it answering all of your questions, right? Is it actually making predictions that are accurate, not accurate? And you can check that out. And on the AWS's website, we have a bunch of sample code that showcase how to do that as well. Yes?
So there are these various algorithms for training the models. So do you have any advice on which algorithms to use in different cases?
Yeah, so we have a bunch of pre-built algorithms, right? And for computer vision, there were three major ones: classification, detection, segmentation. Classification is where you don't really care where the object is in an image. You just want to know what are the tags in an image. Does it have an airport? Does it not have an airport? You don't really care about the location of it, right? Is there forest degradation? Is there not forest degradation? That's all you care about. With detection, it's now, I want to know if that's happening, also where in that photo it's happening, so I can have better coordinates of it, or whatever the case may be. And then segmentation is not just where it is, but you want to know on the pixel level on that image which pixels represent that object, right? And that could be used for mapping or some other use case you might have in mind. Yeah.
So how do you make use of this data to target an audience or more like what exactly they like?
Sorry, say that again?
How do you make use of this data to target an audience?
To target an audience, or?
Yeah, is there any feature that helps you to know what your audience wants from your product?
I'm not understanding the question.
So basically, you have this model, right? To
Yeah.
detect like particular area of the car parking or so. But is there any feature that could help to predict like what people want in certain case?
Well, you can, so basically you give it the data to train where you can get the result that you want to, right? So you just create the labeled inputs that you need. And then from there, you can basically detect what you want. I'm not sure if I'm answering your question, but if not, I'll come afterwards and just yeah. Okay. All right, well, thanks guys. Let me just go to something over here. I just wanted to put up just quick some resources that I thought were really cool. The Earth on AWS data set, more examples. Oh, it's not up now. It's all good. I emailed this out, so just tweet out to me, Canal732, and I'll be happy to just email those 3 resources. And then if you have any questions, guys, my email is kbatra@amazon.com. Thank you.